Okay, I'd like to study the values of the trigonometric functions. Okay, I'd like to study the values of the trigonometric functions. Remember, the trigs are functions because their values are dependent on the size of the angle. We're going to be talking about a 30-degree angle here in a minute for special right triangles. So we're going to look at 30-degree angles, 60-degree angles, and 45-degree angles. The same segment, we're going to use the calculator to find values of the trigonometric functions, which we've done already. So, truthfully, this is really a theoretical topic. To be able to determine the sine, cosine, tangent of a 30-degree angle without a calculator. This is how you would do it without a calculator. It is known that in a right triangle, the side opposite the 30-degree angle is always this side right here, opposite the 30-degree angle, is half of whatever the hypotenuse is. Can you kind of see that this is twice that? So I'm going to make this a 1 and this a 2. I could make it a 2 and a 4. I could make it a 100 and a 200. But why make it difficult numbers when you could just make it a 1 and a 2? And as a result, by the Pythagorean theorem, this would be the square root of 3. So remember that the sine of theta is equal to y over r. In this case, the y value, so picture this in the rectangular coordinate system. Here's your y-axis. Here's your x-axis, and so my y value is this 1, my x value is the square root of 3, and this is my r value in this right triangle. So sine is 1 over 2. And I'm sorry, I should have written here, this is specifically for a 30-degree angle. And you know, while we're at it, let's just see if the calculator agrees. What does it say the sine of 30 degrees is? 0.5, half. That's what the sine of 30 degrees is. So the calculator knows it as well. The cosine of 30 degrees is defined as x over r. And my x value in this problem is the square root of 3, and my r value is 2. I don't have to rationalize the denominator because there is no radical downstairs. The tangent of 30 degrees is defined as y divided by x. In this problem, y is 1. X is the square root of 3. If I rationalize the denominator, it'll be a square root of 3 over 3. So either way. You'll see at the bottom of this page that all of these are written in a table format. So you'll see way down here that the sine of 30 degrees is 1/2. The cosine of 30 degrees is square root of 3 over 2. The tangent of 30 degrees is 1 over the square root of 3, but when you rationalize the denominator, you have this. In a theoretical class, these need to be memorized. You will not need to memorize these for me. To do this for a 60-degree angle, all we need to do is we need to take this 60-degree angle right here and just put it in a x, y, and r kind of fashion. So I'm going to attempt to draw this triangle, but lay it differently. So now what I'm doing, here's the 60-degree angle. Here's the right angle. 30-degree angle got moved up here. This is 1. This is 2. This is the square root of 3. But now I'm thinking of this in terms of this is my x-axis and this is my y-axis. So to find the values for the sine of 60 degrees, for example, the sine of 60 is the y value over the r value for 60 degrees. It's the y value over the r value. It's the square root of 3 over the 2. The cosine of 60 degrees is defined as x over r. And in this problem, x is the 1 and r is the 2. And for the tangent of 60 degrees, I have y over r. So tangent is the y value divided by the x value. So that's a square root of 3 over 1, or we would just call that the square root of 3. I need you to notice something. I need you to notice that the sine of 30, which is equal to 1/2, is the same thing as the cosine of 60, which is equal to 1/2. I need you to notice that the cosine of 30 degrees, which is equal to the square root of 3 over 2, is equal to the sine of 60 degrees, which is the square root of 3 over 2. We're going to talk about that in great detail in probably the next section. But just kind of notice those for a minute. And it's because of this interchangeable relationship between these two angles, which add to be 90 degrees. They are the complements. They, because this is a 90-degree angle, the other two angles will add to be 90 degrees. So we'll talk about that some more as we move on. Let's now talk about a 45-degree angle. And the one thing we know about a 45-degree angle in a right triangle is that there's two of them, because these both have to be add to be 90 degrees, given that that's 90 degrees. Well, if those are equal, then this side and this side are equal. Well, what the heck? Let's make them both be equal to 1. Instead of 5s, because they could both be 5s. But if you put that in the Pythagorean theorem, then the hypotenuse would be the square root of 2. And so again, let's draw the rectangular coordinate system in here. Here's the x-axis, here's the y-axis, and I want to know what the sine of 45 degrees is. Well, it's defined as y over r. My y value in this picture is 1, and my r value is the square root of 2. When I rationalize the denominator, I'll have the square root of 2 upstairs and just a 2 downstairs. The cosine of 45 degrees is defined as x over r. Again, all these definitions need to be memorized. For a 45-degree angle, my x value is this 1, and my y value is the square root of 2 again. So when I rationalize it, square root of 2 over 2. Remember, the sine of 45 and the cosine of its complement are always equal to one another. Finally, the tangent of 45 degrees is equal to y divided by x. And in this picture, my y value is 1 and my x value is 1. 1 over 1, or just 1. Let's just check it out. Does the calculator know that the tangent of 45 degrees is equal to 1? Yes, it does, because it knows the definition is that the side y over the side x in a right triangle where there's two 45-degree angles would always be the same. All right, let's explore just a little bit more in this segment, and I want you to start to feel your trigonometry. So I'm going to draw some pictures a little bit here, and then I'll have you think about it a little bit more on your own. So the cosine of an angle is defined as x over r. And I'm going to have to do this quickly. So here's your x-axis and here's your y-axis, and I'm speaking about a 37-degree angle. So that's supposed to be 37 degrees right there. Here's your side x and here's your side r. If I were to take my calculator and find that, I know personally that the side x is, in comparison to the side r, if I swung it over here, it looks like this side is about 80-some% of the r side. So if I swung that over, it seems to me, I'm just estimating, that it's approximately, the x is approximately 80%. Let's go check it out. So cosine, I'm going to see if I can get this to be over here. Yeah. So cosine of 37.5. Now, I could be way wrong, but wow, not bad. 0.79, or I had guessed 0.80, 80%. So I'm asking you to now start visualizing what you expect the calculator to tell you. So I'm just going to type the next one. Sine of 62.1 degrees. 0.88, and let me tell you, when you 0.884, I'm going to round these to the thousandths place. 4 decimal places. 0.884 is what the calculator told me the sine of 62 degrees is. It knows that the ratio of a 62-degree angle for the side y divided by the side r. So here's my triangle. 62 degrees may be something like this. It knows that this side y and this side r, for this being the 62-ish degree angle, it knows that this side right here is pretty close in length to the side y. If I swung that over there, it's about 88% of it. Let's look at tangent of 80 degrees. I'm going to go ahead and draw this with some straight lines. So an 80-degree right triangle is pretty steep. And tangent is defined as y divided by x. So remember, tangent is defined as y divided by x. Here's my 80 degrees right here. This y value looks like 4 times as big as this. Or maybe as big as x, or maybe even 5 times as big as x. So I'm guessing 4 or 5. It's probably even going to be 6 times as big. This side over this side, because it's y over x. So we check it out and we find out that the tangent of 80.5 degrees is indeed almost 6 times as big. So 5.976 is how I would write that. Cosine of 88 degrees. Let's just let the calculator tell us. So cosine of 88.2 degrees. And look, I'm getting lazy. I'm not closing the parentheses because I know the calculator will do that for me. 0.031. 0.031. That's because cosine is defined as x over r. And for an 88 degree angle, that's almost 90 degrees. So I'm trying to draw that. What happens is that this x side is really, really small in comparison to this r side in this right triangle. So it's x over r, but at an 88 degree angle right there, that's what this angle is, x is almost gone. The same will be true for the sine of 1.3 because it's defined as y over r, and for a I'm sorry, I should scroll a little bit. It's defined as y over r, and for a 1.3 degree angle right here, this little bitty y value in comparison to that r value is really small, and so when we type sine of 1.3, we get a very small ratio, 0.023. Finally, I want to go ahead and finish this page. So do you notice anything special about sine 10, sine 20, 30, 40, 50, 60, 80? So if you would type those on your calculator, here's the sine of 10 degrees. The sine of 20 degrees is 0.342. The sine of 30 degrees we've done recently, it's a half. 40 degrees, 0.643. 50 degrees, 0.766. You're just typing this on your calculator. Sine of 80 degrees, 0.98. Sine of 89.999 is 0.9999. Sine of 90 degrees is 1. Here's why. The sine of an angle is defined as y divided by r. And so in this right triangle that results, as we build it up from 10 degrees, where you're talking about this little y over this big r is about 17%. This is about 17%. You do it again, you go up to 20 degrees, and my y value right here is a little bit bigger than it was here, and I'm comparing it to my r value. If I was doing this with a unit circle, I would be trying to make these hypotenuses equal to 1. A 30 degree angle, then this y value right here is half of this hypotenuse. Let's go to 80 degree angle. This 80 degree angle, the y value right here, this y value is very close to this r value for this 80 degree angle, so 0.98. And when you get all the way to 90 degrees, and I'm just going to draw it with a red line, the side called y is the same as the side called r, so you have the same length divided by the same length. And so